This will be part 2 of the final review solutions. This will be covering the quadratics part. So this is fill in the blank with each term. The shape of a quadratic is called a parabola. It is a U shape, but the actual name is called a parabolic shape or parabola. The standard form of a quadratic equation is y equals ax squared plus bx plus c. Special parts of this thing are the c value, which tells you the y-intercept, and the a value, where if the a is positive, it's going to mean the graph opens up. So if a is positive, your graph opens up like this, and that means your vertex will be the smallest point or the lowest point on the graph, which your vertex will be a minimum, your minimum value. And if your a is negative, the graph reflects and it opens down, and your vertex is now a maximum, the highest point. And your c value is used to find the y-intercept. This line right here is called the axis of symmetry. It cuts your graph into two equal pieces. The important thing to note is that wherever you are, that points will be equal distance away. So like if this is 1, 2, and a little bit away, on the other side 1, 2, and a little bit away will be a point. If this is 1 and like 1.8 away, then this is going to be 1.8 away as well. And then this point right here is called your vertex. Given the following graph, identify the following. The vertex, it's a point. It's located right there. That is the point 3, negative 1. The axis of symmetry, it's a line. It's whatever the x value is of that vertex, and we write it as x equals 3, because that's the equation of a line, where wherever you are on this line, x is always 3. So it doesn't matter what point you are, x equals 3, x is always 3. On the flip side, if you happen to do a horizontal line, that would be y equals a number like y equals 2, where y is always 2. The number of x-intercepts, there are 2 x-intercepts, which are located at 2, 0 and 4, 0. The domain, since the graph goes to the left forever and to the right forever, is negative infinity to infinity. The range is low to high. It's negative 1 up to positive infinity. Notice how I'm including negative 1 by using a bracket, because negative 1 is a possible value. So that's the lowest value up to the highest. It opens up because the arrows open up. And the vertex is a minimum. It's the smallest point on your graph. That's your vertex right there. For 9 and 10, let's use the equation to get all this stuff. You want to remember that we have the formula x equals minus b over 2a, where when you're in standard form, it's ax squared, so your a is 1x squared. Your b would be negative 4, and your c is negative 3. So that your vertex, the x-coordinate will be minus b over 2a, so minus negative 4 over 2 times 1, so that's going to be 4 over 2, which is 2. So far I've got the point 2 comma something, and if I know the x value of a point, I can plug it back in and get its value. So wherever I see an x, I'm going to replace it with 2. 2 squared is 4. 4 and then minus 4 times 2 is minus 8. And 4 minus 8 is negative 4. So this is going to be negative 7. So your vertex is the point 2, negative 7. So 2, negative 7 is right there. I know the axis of symmetry goes through the vertex. So it's whatever that x value is. The y-intercept is whatever the c value is. So it's 0 comma c, or in this case 0 comma negative 3. Because this is 2 spaces away from the axis of symmetry, there's going to be a freebie point 2 spaces away over there. I know it opens up because A is positive. I know I'm going to have 2 x-intercepts because if I were to fill this in going up, it's going to hit the x-axis twice. And the domain would be negative infinity to infinity. And the range would be from negative 7 all the way up to infinity. And if I kind of go up like this, and this, I could do that. If I had asked specifically for the x-intercepts, you could have used Desmos or factoring and solved this quadratic equation, or you could have also done the quadratic formula, 3 ways to do it. Number 10, same idea. We're going to start off with the vertex. So start off with my formula, minus b over 2a, minus, again, my b is negative 4. And this time my a is negative 1. So it's going to be 4 over negative 2, which is negative 2. When I go to plug it in, it's going to be y equals negative 2 squared minus 4 times negative 2 plus 5. PEMDAS says do exponent first, so negative 2 squared is 4. So this negative, this becomes a 4. Negative 4 times negative 2 is 8, and 5. And then negative 4 plus 8 is 4. 4 plus 5 is 9. So your vertex is the point negative 2, comma 9. Axis of symmetry is negative 2. X equals negative 2. It's the line that goes through there. The y-intercept is your c value, so 0, comma 5. Because that's 2 spaces away, there's going to be a point 2 spaces away over there. It's going to open down because my a is negative. And the number of x-intercepts, I know that this goes down and it goes through my points. It's going to hit the x-axis twice, so there's going to be 2 x-intercepts. And again, because this is going to be going to the left forever, that's going to be going to the right forever. My domain is negative infinity to infinity. And my range all the way down up to that high point of 9, including. Solve the following equations. Because I can isolate the squared value, I can just get the squared value by itself, so get rid of addition and subtraction first. So 3n squared equals 72. Get rid of a multiplication or division, so divide both sides by 3. That should be n squared equals 24. And then once the square term is by itself, the way I get rid of something squared is by taking a square root on both sides, realizing that I'm going to get plus and minus the 2 versions. Because if I want to know when n squared is 24, let's say 24 is up here, there's 2 values that happens at, a plus version and a minus version. So I want to simplify as much as possible, so I'm going to break down 24, 12 and 2, 6 and 2, 3 and 2. For each pair, one goes to the outside, the rest remains on the inside. So square root of 24 simplifies down to 2 on the outside, and then the leftover 3 and 2 goes back on the inside as a 6. So plus and minus 2 times the square root of 6 is your answers. This one, same idea, subtract 3. 3a squared equals 75. Divide both sides by 3, a squared equals 25, and when you take the square root, this time you're going to get a equals plus or minus the square root of 25, and we know what the square root is, it is 5. And finally, distributing, these are kind of already factored terms, you want to remember to FOIL, so this is just distributing twice. So if I kind of cover this up, and imagine if I was just distributing, I would distribute this thing twice to each term. So 4a times 2a, 4 times 2 is 8, a times a is a squared. Then 4a times negative 7 is negative 28a. Done dealing with that. I'm then going to distribute this negative 4. So negative 4 times 2a is negative 8a. And negative 4 times negative 7 is positive 28. You're always going to be able to combine this stuff on the inside. So this simplifies down to 8a squared minus 36a plus 28. Same thing over here. 5r times 3r is 15r squared. So remember, in slow motion, it's 5r times 3r. 5 and 3 combined to give you 15. R times r, that's just r squared. That's what r squared means. It means to do r times r. Find r cubed, that'd be r times r times r, and so on. So whenever you're multiplying variables together, you add those exponents up as a shorthand. So r times r is r squared. 5r times 5 is 25r. Negative 4 times 3r is negative 12r. And negative 4 times positive 5 is negative 20. These two combine to give you positive 13r. These are not going to combine because they're not like terms. It says you have 15 of this object, and r squared is a different object than the plain old r. All right, and that was our quadratic review part.